All right, guys, let's go ahead and look at notes 1.1, simplifying expressions. You will notice that some of the notes on this page are already filled in. That is because there are some things on here that we want you to listen to and some things on here that we want you to do. So if it's already written in, that is there to help you. That is a resource. Let's start by looking at some vocabulary. These are going to come up over and over again throughout this entire year, so we should establish them right now at the very beginning. First one is a variable, and I know you've seen this one before. It's a letter or a symbol used to represent an unknown value. So the one that you've probably seen in the past is X, but we can use any letter from the whole alphabet. It could be A, B, Y, Z, Q, R, P, pick one. All letters will work here, and you'll see all of them throughout our notes over the next few days. A coefficient is a constant quantity or a number placed before a variable that multiplies with the variable. So if you see 2x on the page, that means you are really seeing 2 times x. We just don't write it out as multiplication. If you see just a plain letter by itself, for instance, A, there is an invisible ninja 1 hiding in front of it because it's just 1 times A. Like terms are terms that are the same, not necessarily the same coefficient, but the same variable with the same exponents. So if I see 3x and 4x, those are like terms, even though the first number is different, because they both have an x. If I see 2v squared and 3v squared, those are like terms because they both have a v, and both of the v's are squared. If I see 2 and 3, those are like terms because neither one has any variables or any exponents. However, if I see something like 2x and 2x squared, those are not like terms. They both have x's, but their exponents do not match. They are not going to be like terms even though they have the same variable. An expression is a math phrase that consists of numbers, variables, and operations. And operations are going to be our plus, minus, our division, and our multiplication. They will not contain an equal sign. As soon as you have an equal sign, it goes from an expression to an equation. Because there is no equal sign, we cannot solve an expression. So today, when we look at expressions, we are only going to simplify them. Distribution is a type of simplification. It's a type of multiplication. It means that there is a number or a term outside of parentheses, and we're going to multiply that times each term inside the parentheses. So here with this example, I see 2 times x plus 3. So I need to distribute 2 times x, and then again 2 times 3. That gives me 2x plus 2 times 3 is 6. Okay, combining like terms is going to go back to that vocabulary term we looked at a couple moments ago. If we have like terms, things with the same variables and the same exponents, then we can combine them using addition and subtraction. So with this first example, I see 2 plain x's, and I'm going to write that ninja 1 in front of them. 1x plus 1 more x. So I have an x in my left hand and an x in my right hand. That means altogether I have 2 x's. We can add or subtract the coefficients, but it will not change our variables. So let's do a second example. I have 2 x's. I take away 3 x's. 2 minus 3 leaves negative 1. But because I had x's minus x's, that means it's negative 1x. When we simplify algebraic expressions, we're going to use distribution and combining like terms to simplify. So we have this first example that's done for us. So we're going to go over it together, but you do not have to write it because it should already be on the page. So 2x squared plus x. If I look in front of these parentheses, there's nothing there. I could, if I wanted to, put a Ninja 1, but 1 times 2x squared is 2x squared, 1 times x is x. It doesn't change anything. However, here, if I put a Ninja 1 in front of those parentheses, now I'm distributing a negative 1. Negative 1 times x squared is negative x squared. Negative 1 times negative 4x becomes positive 4x. And negative 1 times positive 1 is negative 1. When I distributed the negative 1, that did change the sign on everything inside the parentheses. So now I'm going to look for like terms that I can combine. 2x squared combines with negative x squared. That's like negative 1x squared. So 2 minus 1 gives me 1x squared. Then I can combine my positive x, that's like a positive 1x, and a positive 4x. 1x plus 4x gives me 5x. And finally, poor negative 1 here doesn't get anything else to combine with. It just stays negative 1. Okay, we have a second example here that was started for us, but we are going to finish it. So let's see, they've already distributed the 3. 3 times 2x squared is 6x squared. 3 times x is 3x. But I need to finish the distribution. I have a negative 1 that I need to distribute. Negative 1 times x squared is negative x squared, or negative 1x squared if you'd like to write it. Negative 1 times negative 4x is positive 4x. Negative 1 times positive 1 is negative 1. So let's look for like terms that we can combine. 6x squared combines with negative x squared, and that's going to give me 6 minus 1 is 5x squared. Okay, 3x can combine with 4x. 3 plus 4 gives me a positive 7x. And once again, poor Mr. Negative 1. It's the only one, the only plain number. So it's just going to stay negative 1.
Math department to Ms. Pye's room. Teachers, if you haven't picked up
Okay,
your red
let's look at question number 1 here on the back. We are distributing a negative 1. That gives me 2x squared plus x minus 4. Because again, if there's nothing in front of a set of parentheses, it's not going to change the inside. But then I distribute negative 1x squared plus 4x minus 1. Okay, when I combine my like terms, I combine 2x squared and negative 1x squared. That gives me 1x squared. I combine my x and my 4x, which gives me a positive 5x, because remember, this is a 1. 1 plus 4 is 5. Oh, and this time negative 1 doesn't have to stay by itself. Negative 4 is going to be their buddy. Negative 4 minus 1. Okay, so looking at question number 2, we are going to need to do some distribution here. When I look at this 2x squared, my first instinct might be to try to distribute it, but do you see that plus sign? The 2x squared is not touching the parentheses, so we are not going to distribute it. We're going to bring it straight down, 2x squared. Then I'm adding 4x minus 6x squared, and again, the plus is touching the parentheses. I could put my Ninja 1 here, but 1 times 4x and 1 times negative 6 is still 4x minus 6x squared. So we're going to leave it, just 4x minus 6x squared. With the 9, I need to be careful the same way. It is not touching the parentheses, so I am not distributing 9. I'm bringing it down. Here, I am putting in my Ninja 1. Negative 1 times 6x. negative 1 times 3. So minus 6x minus 3. Now I need to combine like terms. So I'm going to grab my highlighter and let's see. 2x squared combines with negative 6x squared. 2 minus 6 is negative 4x squared. Okay, 4x combines with negative 6x. 4 minus 6 is negative 2x. And then 9 combines with negative 3. 9 minus 3 is positive 6. Okay. Question 3 gives us a triangle and labels the sides. 3x squared minus 4x plus 7, x squared plus 3x minus 5, and 2x squared plus 4x plus 1. And it asks us to identify the perimeter. The perimeter is the sum of all sides. It means I'm going to add all 3 sides. And I could write this out as one long addition problem, or I can just look at my triangle and combine my like terms. Because really, I am adding 3x squared minus 4x plus 7 plus x squared plus 3x minus 5 plus 2x squared plus 4x plus 1. So I'm going to identify like terms. 3x squared, 1x squared, and 2x squared. And there's my x squared and my answer. So 3 plus 1 plus 2 is 6x squared. Now I do the same for the x's. Negative 4x plus 3x plus 4x. And I'm not going to go around in the same order this time because I recognize that negative 4x plus 4x is 0. Those cancel out. So that gives me 0x plus 3x. And then finally, I'm going to go and look at my numbers. Positive 7 minus 5 plus 1. 7 minus 5 is 2 plus 1 is 3. Number 4. The perimeter of a triangle is 6x squared plus 5x minus 5. And the 2 sides are x squared plus x plus 1. And 2x minus 1. So that gives me 2 sides. What is the length of the third side? When I'm thinking about perimeter, it means I am adding sides together. So I'm going to add what I know so far. X squared plus x plus 1 plus 2x minus 1. 1 minus 1 is 0. I'm not going to write that because it's saying plus 0 does not add any new or important information to my problem. Then I'm going to add my x's. 1x plus 2x gives me 3x. And then I add my x squared. X squared plus a whole lot of nothing is x squared. So that gives me 2 sides in my triangle. X squared plus 3x. I know the whole triangle's perimeter, and I know 2 of the sides. So I bet if I subtract the perimeter minus the 2 sides, what will be left will be the third side. So let's do that. 6x squared plus 5x minus 5 minus x squared plus 3x. I'm going to draw in my Ninja 1. Distribute. Negative 1 times x squared is negative x squared. Negative 1 times 3x is negative 3x. And let's bring down 6x squared plus 5x minus 5. I can combine my like terms. Let's grab a new color. I like orange. 6x squared minus 1x squared is 5x squared. 5x minus 3x is 2x, positive 2x. And then negative 5 does not get to combine with anything, so just minus 5. All right, one more problem. Mr. McKeever's fireworks stand. So Mr. McKeever has a fireworks stand, and he decides he needs to test his stock before he sells it to make sure that these are good fireworks. So he takes 2 of the really good rockets and launches them straight up into the sky. The height in feet of each rocket at t seconds after launch is given by the polynomial equations below. So down here, you may have seen that I had the phrase polynomial written out. Okay, poly means many, and nomial, for our purposes, nomial is going to mean terms. So a polynomial expression has several terms separated by plus or minus signs. That's it. So Mr. McKeever has a fireworks stand. He's launching these rockets in the air, and we have 2 polynomial or multi-term expressions that represent the height of these 2 fireworks. We want to know how much higher rocket A has traveled than rocket B. So rocket A can be represented by the expression negative 16 t squared plus 122 t. We want to know how much higher that is than rocket B. So rocket B is negative 16 t squared plus 84 t. And I'm going to keep that inside parentheses so that I'm separating A from B. And if I want to know the difference between their heights, I should use subtraction. We're going to subtract the height of B from the height of A. When I am subtracting and I have these parentheses, that tells me I need to put in my Ninja 1 and do some handy-dandy distribution. So negative 1 times negative 16t squared is positive 16t squared. Negative 1 times 84t is negative 84t. A does not have anything in front of its expression, so we're just going to keep negative 16t squared plus 122t the same. So now I can start combining like terms. Here I see I have negative 16t squared and positive 16t squared. And what's going to happen when I add negative 16 plus 16? They're going to cancel out. That's 0. Negative 16 plus 16 is 0. So all that leaves behind is the t's. 122t minus 84t. 122 minus 84 is 38. So 38t. That is the distance between rocket A and rocket B in feet.